This is question number 4 of exercise 5.2 from the chapter Continuity and Differentiability. The question is, differentiate with respect to x sec of 10 of square root of x. So we are going to solve this question by two methods. The first method is by substitution method. Now to solve this question, we should be knowing this result, that d by dx of f of t is equal to d by dt of f of t into d by dx of t. Okay, where t is a function of x. Okay, so this means that differentiation of a function of t with respect to x, where t is further a function of x, is equal to differentiation of the function of t with respect to t into differentiation of t with respect to x. Okay, so to differentiate or to calculate d by dx of sec of 10 of root x, first of all we should be knowing this formula, that differentiation of sec x with respect to x is equal to sec x into 10x. Further we assume 10 of root x as equal to t. So d by dx of sec of t. Okay, so this now becomes sec of t. Differentiation of sec of t would be equal to differentiation of sec t with respect to t. So differentiation of sec x with respect to x is sec x into 10x. So differentiation of sec t with respect to t would be equal to how much? Sec t into 10t. And on applying this result, this would further be equal to sec t into 10t into d by dx of t. Okay. So we can write differentiation of sec of 10 of root x as equal to sec of 10 of root x 10 of root x into d by dx of 10 of root x. So here in this result we have replaced the value of t as equal to 10 of square root of x. Now further we have to differentiate 10 of root x. So I am going to assume square root of x as equal to u. So differentiation of 10 of u by applying this result would be equal to differentiation of 10 of u with respect to u into du by dx, and differentiation of 10x is equal to sec square x. So differentiation of 10u would be equal to sec square u into du by dx. So on replacing the value, these two terms are written as it is. On replacing the value of u as root x, so this would be equal to sec square root x into d by dx of root x. Okay, now root x is equal to x to the power of 1 by 2, and differentiation of x to the power of 1 by 2 would be equal to 1 by 2 x to the power of 1 by 2 minus 1, or 1 by 2 x to the power of minus 1 by 2. Okay, and here we have used this result that differentiation of x to the power of n is equal to n x to the power of n minus 1. Okay, so these terms as it is, and we have placed d by dx of root x as equal to 1 by 2 x to the power of minus 1 by 2. Okay, now x to the power of minus 1 by 2 is equal to 1 by square root of x. So we are going to have all these three terms in the numerator and 2 into root x in the denominator, which would be my required answer. Now in chain rule, that is, if we have to solve this question by chain rule, first of all we read the question, and on reading the question we get the order in most of the cases, that in which order we have to differentiate. So here the function would be read as sec of 10 of square root of x. So we are first going to differentiate sec, then differentiate 10, then square root of x. Now to differentiate sec of 10 of root x with respect to x by chain rule, first of all we are going to differentiate sec. Now differentiation of sec is equal to sec of something into 10 of something. So here we are going to write this as equal to sec of 10 of root x into 10 of root x into d by dx of 10 of root x. So differentiation of sec of 10 of root x by in chain rule would be done by applying the formula of sec and writing instead of x the terms which are with sec. okay, and multiplying the differentiation of sec with d by dx of the terms inside the bracket or with the sec. Okay, now further differentiation of 10 is equal to sec square x, differentiation of 10x is equal to sec square x, so differentiation of 10 of root x would be equal to sec square root x into d by dx of root x, because instead of x we have root x. So these terms as it is into sec square root x into d by dx of root x, and now d by dx of root x do not require any substitution because it is equal to x to the power of 1 by 2, and differentiation of x to the power of 1 by 2 is equal to 1 by 2 x to the power of 1 by 2 minus 1, or 1 by 2 x to the power of minus 1 by 2, and this x to the power of minus 1 by 2 can be written as 1 upon root x. So this would give me this required answer. So this is how I'm going to solve this question by chain rule. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.